Hi friends, so in this video we're going to take a look at the ratio test. So I'm going to do these two examples that you see here. So the ratio test, just to remind you, what we want to do is we want to compute the limit as n goes to infinity. So we're going to take whatever our sequence is, and we're going to take n plus 1, the n plus 1th term of that sequence divided by just the nth term of that sequence and see what we get. And depending on what we get, we have these different conclusions, and then that helps us interpret the test. So I'm using the ratio test for this here. So the nice thing is that we're taking the absolute value of this, which means I can exclude thinking about this negative 1 to the n. So what I want to do, just to save a little bit of space, is first I just want to set up this calculation. So I have this divided by this, right? And in dividing by that, what I can do is I can just actually multiply by the reciprocal, just to save myself some space. So I just want to compute this out before I calculate the limit. So this is going to give me n plus 6 here. Then with the 5 to the n and 5 to the n minus 1, so I can subtract n from here, so that just leaves me with 5 in the denominator. And so then I'm just left with n plus 5. So now I can see what I'm taking the limit of. So I'm going to take the limit as n approaches infinity of n plus 6 over, and I'll just multiply this out, 5n plus 25. So from here, I can use L'Hopital's rule because I get infinity over infinity. So if I use L'Hopital's rule and I take the derivative of the top and of the bottom, this becomes 1/5. So I can see then that my limit in this case is just going to be 1 over 5. Okay, so now going back to what the ratio test says, so when you calculate this limit, if the value is less than 1, then the series converges absolutely. So this converges absolutely. Okay, so let's take a look at another example. So I'm going to set up the same test. So I'm going to have n plus 1 minus 1, and then this will be n plus 1 plus 4 squared. And then I'll just multiply by the reciprocal, like I did in the last one. Okay, so we've got to kind of sort some of this out. So let's see, this is going to give me n factorial over n plus 5 squared. This is still going to be n plus 4 squared, and then this will be n minus 1 factorial. Now, knowing how factorials work, if I blow out n factorial, so what's the next term? The next term would be n minus 1. I can actually just write this as n times n minus 1 factorial, which allows me then to cancel out these factorials. Okay, so then I'm left with n times n plus 4 squared over n plus 5 squared. And I can really drop the absolute value here since the limit is going to infinity anyways, so it's going to all be positive. So let's clear some space. Let's keep working this out. So this becomes n squared plus 8n plus 16. And then this will be n squared plus 10n plus 25. So now I can take the limit as n goes to infinity. So this is n cubed plus 8n squared plus 16n, and then in the bottom, n squared plus 10n plus 25. So I can tell just by looking at this now, since I have the higher exponent on top, that this is going to end up going to infinity. But just to be, complete with this, if I wanted to use L'Hopital's rule, so I do get infinity over infinity. So I would get 3n squared plus 16n plus 16 over 2n plus 10n. So I still get infinity, over 2n plus 10, sorry. And then if I try to compute the limit, I still get infinity over infinity, so I can use L'Hopital's again. So that'll give me 6n plus 16 now over just 2. So now I can definitely see, right, that this goes to infinity. So according to the ratio test, if this goes to infinity, if it equals infinity, then we say that the series diverges. So this diverges. Okay, and so those are just two examples just to kind of familiarize yourself with the test. If you have any other questions, feel free to always leave a comment or you can drop me an email. And otherwise, I will talk to you guys in another video. Thanks for watching.